Welcome back. In this video, we are going to talk about another one of the important approach of divide and conquer strategy, and name of that approach is mergeSort. By the name itself, you can understand this is also another sorting algorithm. First of all, what we are going to do, we are going to understand this algorithm. After that, we are going to see the time complexity, and then we are going to see the code of mergeSort. Okay, but after that we are going to cover difference between quicksort and mergeSort. So to understand mergeSort, what we are going to do, we are going to take a list of numbers. List of numbers are 2468975331. So to work on a mergeSort, what we are going to do, we are going to divide this number by half. 2468 one part, 97531 is another part, and after that again we are going to further divided by numbers in two parts, and same thing we are going to repeat until and unless we get all the numbers separated. Okay, so let's do that first. Now you can see that all the numbers are separated, 2468975331. Now what we are going to do next we are going to combine these numbers in the same order by we have divided these numbers, but while combining we are going to sort these numbers. Okay, so the last number that got separated is 31. So if I am going to combine, then we will check first which one is the greater. Either 1 is the greater or 3 is the greater. So I can see that here 3 is the greater, 1 is the smallest, so it will look like this. So while combining these numbers, it will look like this. 1 will be here and 3 will be here. Okay, now the next combining numbers will be so if I will check here 2 and 4, which is the smaller? 2 is the smaller, 4 is the larger. 6 and 8, 6 is the smaller, 8 is the larger. 9 and 7, 7 is the smaller, 9 is the larger. And 5, 1, 3, 1 and 3 is the smaller, 5 is the larger. Now let's again further combine these numbers. So before combining this number, let's understand how this sorting process actually works. So this one will consider one array. Let's say I will take it this side as left array. Okay, and this one I will take another array, and this one I will consider as right array. Okay, and the first value here in left I will indicate it as I, and the first value of in R right array I will indicate it as J. Now I am going to compare if it's left array with a right array. Is I is smaller than J? Yes. 2 is less than 6. So I am going to write 2 here. After writing 2, I am going to do I plus plus, so that our new I value will become 4. Okay, and this one will get discarded. Now compare again. Is I is less than J? Yes. 4 is less than 6. So again I plus plus it is going to happen, but I can see that there is no values remaining in the left array, so it's got completed. So if all the value of left array got completed, array got completed, then we will go into a right array. So if any value in right array is still remaining or it got completed, so I can see that all the value of right array is still there. So what am I going to do? I am going to write all the values of right array in our third section. In our all the value of right array, I am going to print it out. That will be 6 and 8. And similarly I am going to do with 7, 9 and 1, 3, 5. I can see that here 1 is the smaller, 3 is the smaller, 5 is the smaller. So all the value of right array is got written here. Now let's check the left array. Left array is 7 and 9, which is the largest, so it is going to write here. Okay, now similarly I am going to do it here. Here again I am going to indicate this value as left array, and another one I am going to indicate as right array. Left array I will indicate the first value as I, and in right array first value I will indicate as j. Now let's compare. 2 is smaller than 1? No. 1 is smaller. If 1 and j plus plus. Now the new j value will be 3, and this one will get discarded. Now compare again 2 and 3, I with j. So if I is smaller than j, yes, 2 is smaller. So in that case scenario I am going to write 2 here, and this one I plus plus is going to happen. Another I value will be 4 and another I value will be 4. Now let's again compare 4 with I and j, 4 and 3. So 4 is smaller than 3? No, 3 is lesser. So 3 is I am going to write here, and j plus plus. Now new j value will be this one, and this one will get discarded. Now again with I with j, 4 is less than 5? Yes, 4 is less than 5. So I am going to write 4 here, and this I plus plus. Now new I value will be 6, and this one will get discarded again. Now compare again 6 with 5. So 5 is the smaller, so 5 I am going to write here, and this one will get again incremented. Now new j value will be 7, this one will get discarded. Again let's compare 6 with 7. 6 is the smaller. If 6 is the smaller, then 6 I am going to, and this one will get discarded. Now the new I value is 8, correct? And okay, now compare again 8 with 7. So 7 is the smaller one. So after writing it down 7, j plus plus, now new j value will be 9, and this value will get discarded. Okay, now compare 8 with 9. 8 is the smaller, so 8 am I going to write here. Now I plus plus. Now this is the end of the left array. There is nothing to write it down, so the complete left array got filled. Now we will check the right array. In the right array I can see that one value is still remaining, that's not completed. So that last value I am going to write at the end of the after end of the loop, this after end of this section. So 1 2 3 4 5 6 7 8 9. So all the values got printed. So this type of sorting we call it as merge sort. And the time complexity of this sort n log n, and this is for best case, average case, and worst case. So we have seen the code of, we have understand the merge sort, and we are also seeing the time complexity of merge sort. Now what are the next thing that we are going to cover? We are going to see how we can write this merge sort in a Java programming language. Okay, for that what we are going to do, we will go to our Eclipse, and we are going to write our code here. So we got our answer perfectly correct. So if we will see the logic that we have written, it is exactly the same that whatever we have explained you in the editor. We are first of all we are dividing them by into two parts and separating. We are separating the numbers until and unless all the values got separated, and once all the values got separated, we are again recombining it with the same procedure by sorting the value. And how we are going to sorting the value? We are taking two array, left array and right array, and we are incrementing the value according to the comparison we are doing, and we are incrementing the value according to the comparison. If left array is smaller, then store the left array, and if the right array is the smaller, then store the right array, like that. And if all the values got filled up and any arrays got left, for example, if left array is got, okay. So we have seen the code of mergeSort also. Now in the previous video we have covered quicksort, and in this video we have covered mergeSort. Now what we are going to see next, we are going to see the difference between quicksort and mergeSort. Let's see. The time complexity of quicksort is order of n log n. That will apply in best case and average case. Okay, and the worst case scenario of quicksort is, and the worst case time complexity is order of n square. But in mergeSort, best case, average case and worst case, in all the scenarios, time complexity will be order of n log n. Okay, quicksort algorithm mostly used in small data sets. Since mergeSort has consistent data speed, then it will work on any data set, either large or small. Quicksort is inefficient for larger arrays, inefficient, and this one more efficient. Not stable. mergeSort is more stable. Mostly quicksort is preferred for arrays, and mergeSort preferred for linked list. So we have seen the difference of quicksort and mergeSort also. So with that, this is the end of the video, and again in the next video we are going to talk about another one of the important programming concept of data structure. I will upload the practice code in the GitHub, and GitHub link I will give in the description section. Okay, please play around with the code so that you will get more clearer picture of quicksort and mergeSort and their differences and how to write that one. Okay, so with that, stay tuned and keep watching videos of Adhyan channel. Thank you.